Go ahead.
My name is Samir, and I am. अरे ये क्या हो गया? स्टॉप कर लो. हेलो.
जी जी,
वो edit कर.
कंटिन्यू कीजिए, एडिट हो जाएगा.
My name is Samir, and I am one of the co-authors for our paper Milankovitch Cycles: Ancient Supporting Facts from Râmâyana and Surya Siddhanta for Recent Discoveries. First half of the presentation will be taken care by me, and then my co-author Rupa madam will take care of for the rest of the presentation. So moving on to the first slide, I would like to explain our meeting agenda, what it is all about. The first part would be introduction. I will just introduce on how does it go. Then what is Milankovitch cycles and different types of it. Then precision as a mathematical tool. Then obliquity of ecliptic, reversal of seasons. Then Ramayana references of extreme winters. Then Surya Siddhanta references, and finally the concluding slide. So this will be my agenda, and both of us will take you through the presentation one by one for every slide. Moving on to the introduction part. So we know that many of our ancient Indian texts have many different astronomical observations recorded, and even for seasons. And these can be analyzed using the property of Earth, like motion of precision, and along with that, Milankovitch cycles. The analysis of precision motion and Milankovitch cycle helps us to identify intensity of seasons across different epochs, and this study is going to be very crucial, which will provide a corroborative evidence for antiquity of our Indian culture that goes back to at least 12,000 BC or even beyond further that. So moving on to the Milankovitch cycles and the types, actually Earth's orbital movements affect quantum of solar radiation reaching top of the atmosphere, and depending upon that, there are different types of those cycles, because these cycles are related to different properties of the Earth, and they are named after a scientist called Milutin Milankovitch, who had hypothesized these long-term effects by analyzing these cycles in great detail. There are three main types of the cycles. One is change in eccentricity, second is change in axial tilt or obliquity, and third is change in orientation of axis of rotation, or also known as axial precession, out of which change in eccentricity is comparatively a minor one, but obliquity and precision are two major effects that we will be having a look after in this presentation. And these different cycles have different time spans and greatly affect the intensity and the length of the seasons, as we shall see later in this presentation. So now moving on to the precision, that is the first part. We know that the rotational axis of the Earth keeps pointing to the different parts of the sky due to mainly the gravitational pull of Sun and Moon. That is known as axial precision. We will show one small GIF in the upcoming slide to get better idea about it. And due to this precision, the equinox and solstice points, what we call as cardinal points, keep moving along the ecliptic, and they keep changing in the background of the ecliptic across all the 27 nakshatras. And the tracking of this precision movement across nakshatra cycle helps us pinpoint a certain epoch when a particular text would have been composed or last modified. This cycle is about 25,700 years. And this is one small GIF we can see. You can see that red line is basically an axis of rotation, and it keeps pointing to the different parts of the sky along its course of 26,000 years. And this is one of the major factors that affects the length of the seasons on the Earth. And depending upon the epoch that we are considering, the seasons would vary. And the direction of this precision is from east to west if we see it from the Earth, and its rate is roughly 50 arc seconds per year. Moving on to apsidal precision, actually line of apsids is basically the elliptical orbit of the Earth where the two focal points are available, and that also undergoes a precision, due to which periapsis and apoapsis positions keep varying, and direction of this precision is opposite to that of axial precision. And obliquity is one more important type of Milankovitch cycle, where the inclination of Earth's orbit to the orbital plane keeps changing between 22.1 degrees to 24.4 degrees, and more the obliquity, more will be the intensity of the seasons. And this is the last slide which I will be dealing with. This slide basically shows you the different uh, positions of the seasons relative to the sun that Earth undergoes, and it shows that peak of Grishma happens near periapsis, which is directly opposite to what we see today. And the northern hemisphere summers are harsher because Earth is closer to the sun, and winters are colder because at that time Earth is farther away from the sun. And this slide can be better understood from the Kepler second law GIF file that we have shown here. Whenever the planet is near to the sun, it moves faster, and when it goes farther away, it is slower. Now I request Rupa madam to take over from here for the rest of the presentation. Thank you. Thank you very much. I will stop my screen sharing. Ma'am, directly go to that slide.
मैम स्टार्ट कीजिए.
रूपा मैडम म्यूट पे है. मैडम आप म्यूट पे है.
So I will share the screen again. Can you hear my voice now?
Yes, yes.
So what Sameer said just now, I will take over from there. The reversal of the seasons. So when the actual, due to the actual precision and precision of equinoxes, in today's time, it points towards the Polaris. During Râmâyana time, it was pointing towards Brahma Rashi. And with that, one more effect was there, and that was the apsidal precision, which Sameer ji just explained. When the planet comes nearer to sun, it slips away very fast, and you can see that Kepler's second law in that GIF, that how it becomes slow when it goes away, and how that planet comes faster when it comes nearer to the sun. Now, in today's time, we feel that the winters have just come and passed away very quickly. So this is the effect of this Kepler's law. And this is due to the apsidal precession. That is one of the Milankovitch cycle also. Now, the same when applied during Râmâyana times. Why I say that this is applicable there? Because winters were longer during that time, and in our time, winter just goes away very quickly. So that kind of impression due to the experientiality of the seasons that came into mind of the writer also, and whatever he was experiencing, he was writing it there. So what does Kepler's law say that I explained? And the same thing is asked in the Surya Siddhanta also. So in Surya Siddhanta, it asks that Grishme Tivra Karo Bhanur Hemante Tatha Vidha Kiyatit Tak Prakara Prapti Manar Nikati Kinchatai. That is asking that how many types of measurements of the rays are there. So kara means rays. So ग्रीष्म में जो rays हैं वो आ रही हैं तो वो कितना जल्दी आ रही हैं. So how these are being measured, and for that matter the answer was given the atya sannataya ten grishme tivra kararave deva bhage suranam tu hemante mandatani. So it gives an idea of the Kepler's law itself in Surya Siddhanta. So there again asked how many types of kara, and it has been given briefly here, and many other aspects of that has been lost. Note that the Sanda has Manda and epicycle reference too in Surya Siddhanta. That means that one Manda was known, other than the Shigra, the Manda was known. But for the Shigra, here the word Tivra has been used, and Tivra Kararave, and the Kara means the rays of light of sun. So what is the references that we get from Râmâyana? That is, I have given here. In every Kanda, there is a reference to if they are remembering something from the past or are experiencing during that time. It has been very beautifully mentioned about the Hemanta, Shishir, autumn, Sharad. Hemant is like the end of that a peak of winters, and after that Shishir. So all these things are being mentioned in different kandas there. But after that, we find that few of the words that gives us a astronomical pointer, and that is the scene near Godavari, and other is the Nakshatra Pushya that leads the night sky, and the evidence of snowfall near Godavari is also mentioned there. It was happening due to some kind of disturbance in the western wind, and that has also been mentioned in one of the shloka in this same sarga. Now coming back to where this Pushanita Himaruna verse is pointing us to. So it is pointing towards the winter solstice, because it is happening like the whole winter night is being pulled by the Pusha Nakshatra, not the Pausha month. So we have to be very specific here to understand that Chitra is month, opposite of Chitra will be the month name. So with the help of the cardinal point, when we see that when the Chitra is appearing with the full moon, that is the time we are having Chaitra month. So likewise, when the Pushya was setting with the sun, that means that it is now pulling the night up. So when it was happening, because it was happening around very near to the winter solstice point. And likewise, we get all the 4 cardinal points, which only points to 12,000 to 13,000 BCE. So these are the cardinal points and the lunar month names that I have given here. And the same thing is being explained in Surya Siddhanta, the same reference that I explained in the Kepler's law slide. The same thing is explaining the condition of Ramayana, because in Ramayana winters are so long, and Lakshman is also speaking with Rama that and like काफी दुखी है कि why Kaikeyi has done this to them, and that kind of thing is coming from the Aranya Kanda. And likewise, all the kandas are having different sets of memories, but maximum of the memories are only going back to from Sharad till the early springs. So what is the conclusion here? We applied Milankovitch cycle for the ancient text, and it proves that the seasons were different in each hemisphere in those days, and that is what we see today. The major factor for seasonal change are obliquity of ecliptic and axial precession, while the minor ones being changes in eccentricity and apsidal precession. So apsidal precession is giving just an imagination. It gives us an imagination how fast that time passed away, and whichever was the slower season that was being experiential, due to being experiential, that was more visible in Ramayana. So the references to autumn, Hemant, Shishir, early spring. Hemant is like the winters. Hemant and Shishir are winters, are abundant with respect to Grishma and Varsha, since the seasons are experiential that I explained. And this methodology independently corroborates the late Pleistocene time of Ramayana. So there are many other factors to corroborate the Ramayana time, but with the help of the experientiality of the seasons, we concluded here that due to the obliquity it was harsh, and again due to the apsidal precision, the quickness and the slowness of the seasons were experienced, and that is very beautifully explained in Ramayana by Valmiki ji. And he has given a complete observation-based poetry to us, which is nothing but an itihasa. So I will conclude it here. Thank you. Back to Vibhuti ji.
Madam, press next slide.
Yeah. Thank you so much. So we will